So in example 2, we're comparing Murray's vanilla wafers to Nabisco, and we want to prove that less than 50% prefer Murray. So this is a taste test. So start once again with what you want to prove. HA, in this case, is P less than 50% or less than 0.5, which means the null hypothesis H0 is P greater than or equal to 0.5. That's our first step. Our second step is to calculate our test statistic. So we need to calculate our sample proportion first. In this case, 42 out of 250 chose Murray's. That is a proportion of 0.168. So we can get our test statistic based on this. Our test statistic is always p hat minus p over the square root of p 1 minus p over n. So we plug in what we know. P hat is 0.168. P is what we're comparing P against, which is 0.5. And that's the square root of 0.5, 1 minus 0.5 over n. And n in this case was 250. So you crank out the math here. And when you do crank out the math, you will get negative 10.5 as our test statistic. So that is step 2. Step 3 is find the area under the curve that relates to this test statistic or that corresponds to this test statistic. Once again, this is a z distribution. Negative 10.5 is going to be way, way down here. In this case, we want to test less than, so we want the area less than. That area is my p-value. So this is something that happens quite often on a hypothesis test. Not always, but quite often. And that is getting a test statistic that is not included in the table that you're used to looking at. So you look at the table, and the table only goes down to what? It goes down to negative 3.4 and up to positive 3.4. So if you get a value that's bigger than 3.4 or smaller than 3.4, that means there is very, very little area beyond those values. Hardly no area is beyond those values. If you think about the empirical rule, 99.7% of the observations are within 3 standard deviations. So if you get beyond 3.4 standard deviations, you're getting almost none of the area underneath of this curve. So basically, anytime that you get a value that's this far away from the mean or this far away from 0, then the area that corresponds to that value in the tail is basically 0. So the p-value here is essentially 0, and that will always be the case when you get a value beyond the outcomes presented in the table. So then, in this case, our p-value is 0, so it's obviously less than alpha. Alpha was 0.05, the p-value is less than alpha, which means we can reject H0. That's what you can always do when you reject H0. In this case, since we can reject H0 and say it's false, we can conclude that HA is true. So therefore, we can conclude that Murray's is less preferable. And in this case, we are 95% confident of this conclusion because our alpha is 0.05.